Okay, girls, so we're going to start with our topic on like terms. So check in your outline which pages of your booklet you need to cover. I'm going to go into the booklet. This year is page 4 in in Roman numerals. So if I see here, this page is the one that I have here. So now I'm going to close the thumbnails. Good. Okay. So like terms. What are like terms? So terms that have exactly the same pronumerals. So this is so important that I'm going to write it again. What are like terms? Like terms, these are terms that have the same pronumerals, and I'm going to write this in blue. Okay, this is very, very, very important. So I'm going to write some examples here. The other part that is very important is that the order doesn't matter, and you're going to see what I mean by that in a minute. And then we're going to look at the examples that are in your notes, okay? So let's look at some examples here. So, example 1. If I talk about A and 5A. Oops. Okay, what is the pronumeral in the first term? A, agree? And what is the pronumeral in the second term? A. It has a coefficient of 5, but the pronumeral is A. So they are like terms. They are like terms. I'm going to write it like this. Good. Let's look at another one. AB, and I'm going to write this and then let's say BA. Okay, so what are the pronumerals in the first term? A and B. And what are the pronumerals in the second term? B and A. So they're written in different order than these ones, but is it the same? Do I have one A on both? Yes. Do I have one B on both? Yeah, so they are like terms. Good, let's talk about another one. 7x and 7. Okay, what is the pronumeral in the first one? X, agree? 7 is the coefficient, agree? Now, what is the pronumeral on the second term? Do I have a pronumeral? No, actually, this term is a constant because it doesn't have a pronumeral. So even though both of them have a 7 in this case, they don't fulfill these criteria. They don't have the same pronumeral. So these are not like terms. Okay, let's look at another one. Y and y squared. Okay, what is the pronumeral that I have in the first one? So I have one y. What are the pronumerals here? You might say, only y, so they're the same. Is it only y? What does this little 2 means here? It means that I'm multiplying y times y. So in other words, this is the same as if I had y times y, agree? So how many y's do I actually have in the second term? I have 2 y's, and here I only have 1. So they are not like terms. Okay, let's look at another one. 8x squared and 3x squared. Okay, what is the pronumerals in the first one? So it's x squared, so that means x times x. And in the second one, x squared, x times x, same pronumeral, yes. So they are like terms, okay? Wonderful. Let's look at examples of what we have on our notes. So it says here, like terms, 4a and negative 7a. So this is a good example because it's saying the coefficient here is positive 4, the coefficient here is negative 7. But that doesn't matter because what matters is that they have the same pronumeral. What is the pronumeral? A and A. So yes, they are like terms. What about this one? 7ab and 12ba. So it's using the same example in different order, the pronumerals, but I have 1a, 1b, 1a, 1b. So yes, they are like terms. What about this one? 12pqr and negative 8rpq. So the same thing. So I have the coefficient here is positive, the coefficient here is negative, but do I have the same pronumerals? 1p, 1p, 1q, 1q, 1r, 1r. Yes, they are like terms. Okay, it says here that these are not like terms. Let's see why not. I have negative 10a and 14ab because the second term has a b and this one doesn't have a b, okay? And here 4bc and 13cd. So they have in common c, but this one has a b and this one has a d, therefore they're not like terms, okay? Now, the second thing that we need to know about like terms, and I'm going to go here, is that like terms can be added and subtracted. And that's what is called collecting like terms. So we can add them together or we can subtract them. Collecting terms. So we're going to look about this and some examples here. So let's do some examples of collecting terms. Usually, when you have to do this type of exercises, they're going simply to say simplify. So let's look at here, because here it says example 1. Simplify the following if possible. Why is it saying if possible? Because if they're not like terms, you cannot add them or subtract them. So you have to say it is not possible or can't be simplified. Okay. Let's look at this one. So I have 7x plus 10x. So again, I'm going to model the way that I want you to do it in your book. So example, and you're going to write A. So it's 7x plus 10x. Okay, so in this case, this one has 1x and this one has 1x. Therefore, they're like terms. Therefore, I can add them. I do the operation like this operation that is between them. So here the answer will be 17x. And that's my answer. I should have left a space there so that I could actually write it better. Let's do B here. B says 15y take away 2y. Okay, you try to do B and C from here. You have it in your booklet. And after you have done it, you can watch, pause, and then you can watch it to see if we get to the same answer, okay? So I have to check, are they like terms? Yes, they are. 15y take away 2y. This is going to be equal to 13y. And that's my answer. Now C. 20ab plus 12ba take away 3ab. So the first thing that I'm going to check is, are all of them like terms? AB, this one is BA, and this one is AB. Yes, they're all like terms, agree? So I can add them or subtract them. So 20 AB plus 12 is going to be 32 AB. Take away 3AB is going to be 29. AB, and that will be my answer. Okay, wonderful. Okay, then it says, sometimes not all terms are like terms, so only simplify the terms which are like terms. Okay, so you only simplify the ones that are like terms. If there are no like terms, then a state can't be simplified, and I already said that. So if you cannot simplify, you just say this, can't be simplified. Remember, when collecting like terms, always use the operation addition or subtraction that comes before the term. So we're going to do example 2. We're going to do this example, and we're going to copy it. Again, as I said, I'm modeling exactly what I want you to do. So this was, I'm going to rub something here. Example 1. And here we're going to do example 2, and I want you to write it exactly the same way in your notes. Example 2. And you're seeing that I'm copying and not just writing the answer. I'm copy the question and then I work it out. I want you to do it that way in your book. So 20x plus 14x plus 5y take away 2y. Okay, I suggest that when you're collecting like terms, to use color pencils, okay? And you're going to highlight, like for example, or underline, like in different colors, the like terms. So I'm going to start with 20x. Which one? So 20x, which one is a like term with 20x? This one, 14x. And notice that when I'm underline, I'm taking this symbol that it comes with that 14x, because this is the symbol that I have to add. That's what it's saying here in the notes when it says here. Remember, when collecting like terms, always use the operation addition or subtraction that comes before the term. So it's referring to this symbol. Use this operation. So perfect, I have those ones. And then in green, I have plus 5y and then take away 2y. Wonderful. So we're going to do these ones underneath. So 20 plus 14 is 34x. And then 5y take away 2y is going to be 3y. Now, notice two things that I did here. First, I only combined the blue ones, and that's what is giving me the 34x. So that's giving me this part here. But I couldn't collect them with the ones that I have here in green, because that's a different term. These blue ones and these green ones are not like terms. That's why I cannot put this together. So I have to only to put the blue ones, and that gives me the 34x. And then the green ones give me the 3y. First thing that I want you to notice here. The second thing that I want you to notice here is that when I did these two, I said positive 5 take away 2 is going to be positive 3y. That's why I write this positive, because there is an operation between these two. Even though I cannot collect them and I cannot put it together, I have to write an expression. I cannot write them simply as 34x and then 3y. How are these connected? Why are they part of the same expression? So I have to put that symbol there, okay? Wonderful. If my answer would have been negative, then this will be a negative symbol. So it depends on your result of your operation, okay? Now, I want you to do B and C. Pause the video here and try to do them and then watch my video. So I'm going to do B here. So it says 8a plus 2a take away 3d plus 5d. Okay, so in blue, a plus 2a, in green, negative 3d plus 5d. Wonderful. So 8 plus 2 is 10a, and negative 3 plus 5, and you can use your number line if you need it, is going to be positive 2. D. So you can see here why adding and subtracting integers become very, very important. I'm going to do this D much more clear. So this looks like a D and this looks like an A. Wonderful. Let's do C, and then I'll finish this video and continue in a different video. 6F plus 7G, take away 3H. Okay, like terms. I have an F here, I have an G here, I have an H here. I don't have any like terms, therefore what do I write? What it says here, can't be simplified. So you just have to write can't be simplified. Wonderful. I'll continue in the next video. Thank you, girls.